Hi all, welcome and thank you for joining Israel Cloud Summit. On this session, we'll review how we can keep application availability during a Kafka consumer upgrade or scaling. And we'll start with a quick Kafka overview, and then we'll see a very interesting use cases for Kafka group rebalancing. And then we'll have a deep dive overview to understand exactly how Kafka consumer group rebalancing is working. And then we'll see how we can even customize the partition assignment logic on the consumer side. And then we'll summarize what we learned today in this session. So my name is Teila Attar. I am lead software architect at Amdocs Microservices Management Platform. At Amdocs, we have 3 billion users who use Amdocs platform. We have 1.7 billion transactions per day and more than 350 companies around the world in different segments like telco, finance, and media. So we developed the Amdocs Microservices Management Platform once we started our cloud journey. And the idea was to build a unified infrastructure for our cloud native application, and for PubSub we selected Kafka. So Kafka is one of the most popular open source, and it provides a distributed event streaming platform. So let's look on Kafka. So Kafka runs as a cluster, which has one or more server that can span multiple data center or even a cloud region. And each cluster has at least one broker, which is the server that forms the storage layer. If we look on the event of Kafka, which is also known as a Kafka record, we'll see that each event has a key, the value itself, which is the payload, a timestamp, and optional metadata header. And also, each event is associated to a specific position in the topic partition, which is the offset. So if we look on the topic, we'll see that the topic has one or more partition that can be also on different data center, because we have different replicas on different brokers. So each partition has a leader replica and also a optional follower replica, and each replica exists on a different broker. So we use this Kafka topic. So we have the producer, which are the client application that publish events to Kafka. And we have the consumers, who are the client application that consume events from Kafka. And we can have per each topic multiple producer and multiple consumers. So for consumers, we have also the concept of consumer group, which is a set of consumers that cooperate together to consume from some topic. So if we take, for example, our application, and let's say we have our shopping cart microservice. We deploy our application in Kubernetes. And in this scenario, we have now 3 instances of shopping cart microservice. So each one of them is member in shopping cart group. And then during the consumer group rebalancing, this is the process where all the partitions are splitted between the members in the group. So we can see here in this example that we have 3 members in our group, and we have one topic with 3 partitions. So in this case, each member is assigned to a single partition under this topic. And now let's review some use cases for consumer group rebalancing. So let's start with the scaling scenario. So as we say before, we have this example of a shopping cart microservice, and we have currently 3 pods. Now let's say we reach to a peak hour, and then we scale out. So 2 more instances were added. So now the group rebalancing is triggered, because now we need to transfer some of the owned partition from the existing consumer to the new joiner. So now after some time, we're back to normal, so we're scaling back. And now these 2 members left our group, and now we again need to trigger the rebalancing in order to move their owned partition to the remaining members under our group. Other scenario is a full replacement of consumer in consumer group. So here we can take, for example, the scenario of application upgrade via Blue-Green. In this scenario, we have the blue namespace, which is our production environment. All the production traffic goes here, and it's connected to backend services, in this case the Kafka cluster. Now we want to deploy our new application version to production, but we don't want to have downtime, so we deploy our new version on different environment. So this is the green namespace. But we connect to the same backend services of production that we have, so to the same Kafka cluster, to the same Kafka topic. But here it's important that before we are doing the switch, so only the active Kafka consumers are the blue consumers. Okay, you can see that all the partitions are assigned only to the blue members. The green consumer are not getting any assignment. So after we certified our deployment and we are ready to switch to green, only then we are doing the opposite. Only the green consumers are assigned to our partitions, and the blue consumer are not getting any assignment. Okay, and another scenario is a fully separated Kafka cluster. So here, for example, we have the disaster recovery scenario and the active passive model. So here we have our production. This is running on the primary site, and we are connect from the primary site to the primary Kafka cluster. But then for backup, in order to support a failover scenario, we deploy our application also on the secondary site. But here the difference from the previous use case that we have different Kafka cluster on the secondary site, but we must keep our application up to date, right? Also on the secondary site, so we'll be able to switch to the secondary site in case of failover. So we are running Kafka replication from the primary cluster to the secondary cluster. But as you can see, as long as everything fine with the primary site and is live, only blue consumers are consumed from the Kafka topic and from Kafka cluster on the primary. In case we need to have the switch, only then we are activating the secondary site consumer and we are starting to consume from this secondary cluster. And we know to start from the exact same point we stopped on primary because we are using the same group name, and also our application replicate also the offset, not only the data. After we review some of the use cases, of course there are many more use cases, let's understand how consumer group rebalancing is working. So Kafka supports two rebalancing protocol, the cooperative and which is the newer one, and also the eager protocol. And the idea is to define a partition assignment and revocation policy that all consumers members under our group must follow. So let's start with the eager rebalance protocol. So here the idea is that whenever we have a rebalancing, all the consumer must revoke all their own partition. So if we took on our example, now we have the shopping cart group with 2 members, and we are subscribing to single topic with 6 partition. So now we have a assignment of 3 partitions to each one of the members. Now let's say a new member is joining our group. So now all the existing members must revoke their partitions assignment, so they cannot work, they cannot consume any event during rebalance operation. Then we have the recalculation of the assignment, like how to split now the partition between our updated members in the group. And now we'll see that after we're done with the calculation, we have per each member assignment of 2 partitions, and now the consumer can resume and continue work and consume event. On the cooperative, on the other end, it's different. Whenever we have rebalance, still the consumer can keep their own partition. It means that, same example like before, we have 2 members with 6 partitions. Each one of the member owns 3 of the partitions. Now a new member is added. In this stage, consumers should not revoke any of the partition. They can continue work. They just need to notify what is their own partition. And then a recalculation is done. And then let's say that now our decision is that the first 2 partitions should be moved to the new joiner. So now only these 2 partitions, let's say it's the 2 first partitions, as you can see, revoked by our current members. And only after this partition were revoked, only then the new member will get the assignment of these 2 partitions. But as you can see, all other partitions, no impact on them, and consumer can continue and work and consume event. It's available since Kafka 2.5. Okay, now let's understand who is invoke this rebalance operation. So let's start with the server side. We have the group coordinator, which is one of the broker. So per each one of the consumer group, one of the broker is acting as a consumer group coordinator, and this coordinator orchestrates all the rebalance operation. And then on the consumer side, we have the group leader. So the coordinator select one of the member from our group to act as the group leader, and the group leader do the actual assignment decision logic, like how to split the partitions between all the members. So also Kafka provides some embedded out-of-the-box consumer assigner protocol. So we have the range assigner, the round-robin assigner, and the sticky assigners for the eager and also for the cooperative. But also, since it's run on consumer side, we can also provide a custom assigner. So how we do it? So if we want to provide our custom logic, we just need to implement this interface of a consumer partition assigner. And if we look on this interface, we'll see that we have the subscription user data method. And the idea of this method is that each member inside the group can provide additional metadata to the group leader. So group leader will be able to make the partition assignment decision based on this information. For example, the current deploy availability zone per each member, or the activation status, like we saw before, right? We had the use cases that we need to have activation and deactivation, like in blue-green during switch or rollback, or in case of a disaster recovery, once we need to switch to the secondary side for failover scenario. So all such information can be passed by the members. And then we have other method, the assign method, which is invoked only on the group leader. And here we have the actual logic, okay? So the logic how to split the partitions between all the members done here. And it's very good because it's very easy to implement our custom algorithms or logic based on our use cases. And let's look on one more interesting use case. Let's say we have a Kafka cluster that span a multiple availability zone. So in this case, we have three brokers. One it's on the US West, and two other on the East, in East A and East B. And also our clients are located on a different availability zone. So before Kafka 2.4, the only option was to consume events directly from the broker that hold the leader replica. Okay, so if we got assignment to some partition, we are enforced to connect to the broker that hold our leader replica. But now with this new feature on Kafka 2.4, we can also consume directly from the follower replica. So by default, this is done on the broker side. We have the leader replica selector. It's further to support backward compatibility, but also Kafka provide now new selector of replica aware selector, and this is also can be customized. You can provide your own implementation for it, but by default, if you just use this rec aware selector, it means that from the client side, you set what is the rec ID. So in this case, let's start with the first one, the West, and also on the broker, you configure what is the rec ID, and then if some of the replica it doesn't matter if it's the leader replica or the follower replica, then the consumer will connect to the closet replica. And what we saw before, that we can do also the consumer side algorithm and logic, so it's also useful here, right? Because if we don't have a replica on each one of the availability zone, as we can see here, we have a replica only on two availability zones per each topic. Like per each topic partition, we have only leader replica and one follower replica. So also here in the consumer logic, by the group leader, we can assign per each member only a partition that at least one replica exists on its availability zone. Okay, so this is also one of the use cases when to use this consumer assigner logic. So let's summarize. We learned that Kafka Consumer Group Rebalancing is crucial part in Kafka Consumers Management. We saw that the partition assignment logic can be done on consumer side, which is very good because then we can provide our custom logic and to support all our challenges in our cloud native application, like activation and deactivation of consumer based on some configuration parameter that members will provide to the leader, and also to reduce latency and cost by the availability zone selection of each partition. And also, if we have use cases that our consumer are consumed for multiple topics and we have unbalanced load between the topic, and we want to use the cooperative sticky assigner, but out of the box assigner just split it cross topics. So we can reach to a situation that each topic is fully assigned to one of the consumer, and it's not good for us because let's say some of the topic are the DLQ topic or they don't have too much balance, and we want to do it per topic basis. So this is also another good scenario to implement your own custom partition assigner. Here are some reference of Kafka improvement and other reference for information from this session. And just to let you know that we have an open position at Amdocs also in my own team. So you are welcome to look, to apply and contact us. And thank you for joining and enjoy your rest of the Cloud Summit.